Hey guys, I am pre-recording this lecture mainly because of our accreditation visits. We are in meetings today, and I didn't want to get behind in classes, so you all can watch this video on your own, and then if you have questions, then you are more than welcome to write them down, and we'll discuss them on next Monday. You'll also get a pre-recorded lecture for Wednesday. So if you want to watch from home, I'm fine with that. Just as long as you do watch the lectures, because you do have a test coming up that's on the first 4 chapters. So today we're going to talk about articular systems, or joints. Articulation is a fancy word for joint. And the purpose of those joints are that they allow motion, they bear weight, and they provide stability. There's different types of joints. Hold on one second. Let me advance my slide. There are fibrous joints, and what a fibrous joint does, it's got a thin layer of periosteum between 2 bones. If you think about the suture joints in the skull, if you look at the skull, you should have a picture of it in your textbook. If not, I will point it out to you when we get back in class. But if you think about the skull, there are little lines in between each bone section of the skull. That is a fibrous joint. It's also known as a synarthrosis joint. And the purpose behind the synarthrosis joint is to allow them to interlock so that virtually no motion occurs. You don't want your skull sliding around where your brain is. And if you think about people that have like strokes, or they have TBIs, traumatic brain injuries, when their brain swells, they have to take them in and remove a portion of their skull. That's because with the makeup of that fibrous joint won't allow for that additional brain swelling. So they have to remove a portion of that skull to allow the brain to swell. Okay, then the next type of fibrous joint is a syndesmosis joint. These types of joints, they allow for just a small amount of twisting or stretching. If you think about your tibiofibular joint at the ankle and the radio ulnar joint at your wrist, those are examples of that. They're not real mobile, but they do allow for some twisting and stretching movements. Okay. And then the gomphosis joint, we're not going to worry about that one. We don't deal with that. But that is just know that is the joint that is between, it's a dental socket in the middle of the mandible and the maxilla. And it's referred to as a Pagan socket. We really don't deal with those, but just you need to know that. And then you have cartilaginous joints. These joints are made up of like a hyaline cartilage or a fibrocartilage that are between the 2 bones. The sternocostal joint is an example of that type of joint. They're also called anti-arthrodal joints because they will allow a small amount of motion, like bending or twisting, and some compression, but they provide a great deal of stability. Okay. Now, the next type of joint is the one that we're going to focus on from in kinesiology from this point forward. It's the synovial joint. These are what you think of as a normal type of joint. Okay. Um, there's no joint or no direct union between the bone ends. Instead, there's a cavity that's filled with synovial fluid. Okay. That synovial fluid is what makes up the let me see how I can explain it best. The synovial fluid provides protection to keep from friction when the joints move. They're also called diarthrodial joints. Okay, you will hear me refer to it most often as diarthrodial joint because that's the way I learned it. But diarthrodial joint and synovial joint, same thing. Diarthrodial joints allow a great deal of movement, free movement. Okay. Um, well, there's different types, and we're going to get ready to go over those. The axial. Okay. If you think back to when you took anatomy and physiology, when we discussed the axis and the planes that movement occurred on, which we are going to go over again and again and again before the end. The uniaxial or non-axial joint, sorry, that tends to be a more linear movement. And those joints kind of glide over one another. If you look at page 23, table 3.2, they have examples of that and the joint motion. So an example would be your intercarpals. Think about your carpals. Those are your wrist bones down on your wrist. Those don't really move in a typical joint-like manner. They sort of glide when you move your wrist into like radial and ulnar deviation. So that's why they are considered non-axial. Then you've got your uniaxial joints. Those are your hinge joints. Your knee and your elbow are the two most common that you think of when you think of a hinge joint. That allows movement in one plane and one axis. Okay, una meaning one, so it's one axis, one plane. Next, you've got your biaxial joints. Well, if uniaxial allows movement in one axis, then biaxial would allow it in two. Your biaxial joints, those are found at the wrist. They're found at the wrist and the MPs, metacarpal phalangeal joints. They allow for flexion, extension, abduction, and adduction. Okay. There is no rotational movement at those joints. All right. Then you have the last type, and that's a triaxial. So triaxial would allow movement in three different planes around three different axes. Think about a ball and socket joint. Your shoulder and your hip would be considered triaxial joints. They're also referred to as multi-axial. Sorry. They allow, this type of joint allows for a lot of freedom of movement because it moves in all three planes, but they are most often to be injured. They're not quite as stable as the other types of joints. Okay. So let's move on from types of joints to the structure of joints. Joint structure. When you look at a joint, you've got bones. Normally there's two bones that are connected to each other, and they're surrounded by ligaments. A ligament connects bone to bone. Okay. Tendon connects muscle to bone, but right now we're talking about ligaments, and that connects one bone to another bone. And that ligament is what allows for movement between the two bones. Um, Ligaments are also non-elastic, which means they keep the bones together in close approximation. Um, the more you'll hear the term joint laxity over the course of the program. That what that refers to is the elasticity in a ligament. You'll see that quite a bit as a person gets older, or when someone's really active as they're younger, and then they tend to get less active as they get older. The ligaments don't repair themselves. So if you stretch a ligament, such as like in a gymnast, um, that ligament becomes elastic, and it allows for bones to kind of separate, and then you get some issues. There are surgeries and things like that that you can do to help with the ligament elasticity, but just know that that's what happens. Uh, when a ligament surrounds a synovial joint, it's called a capsular ligament. Um, and every synovial joint has a capsule that surrounds and encases the joint. Um, Within that capsule, there's synovial fluid, and that is a thick, clear fluid, and it lubricates that cartilage. Um, it helps to reduce friction. It helps to allow free movement. I mean, it also provides some shock absorbent. Um, in the case, if you think about like rheumatoid arthritis, the swelling and the redness that happens in those joints, or I'm sorry, osteoarthritis, that's really an inflammation of the synovial fluid is what causes that. Um, when you have a person who needs a replacement of a joint, such as like a hip or a knee, that's normally because that capsule, or that protection that is in between those two joints, has just kind of over the years, that's why it's called a wear and tear disease with osteoarthritis. It's over the years, it's just kind of worn out. So then when they walk, or any type of movement that occurs in that joint, is essentially bone on bone. And they will do a replacement of that particular joint to keep the person free from pain and to be able to move. Okay. And then you can look up, yeah, about the cartilage and the tenda and the bursa. The cartilage, as you know, is a dense fibrous connective tissue, and it can withstand a lot of pressure. And then you've got the fibrocartilage that acts as a shock absorber, and it's present in synovial and cartilaginous joints. Um, the intervertebral discs, and we will be discussing this when we go over the back, that is in between each of your vertebral bones. Um, those bones are built to withstand a lot of shock. Okay. Now, as I said before, you've got tendons and you have ligaments. Ligaments connect bone to bone, and a tendon connects muscle to bone. Each joint that moves, each of your diarthroidal joints has one of each. Well, at least one of each. Some have more than one tendon. Um, if the tendon breaks, then you can't move that joint because you have no muscle to pull it. Okay, there's no muscle to pull on that joint. So then you've got your bursa. They are small pad-like sacs, and they're found in most joints. You normally see those in joints that get the most friction between tendons and like bony prominences, things like that, is where you'll see most of your bursa. Okay. Next, we're going to go over planes and axis. Don't get alarmed. We will go over this again. It's very important to know this information. So we will be going over this again and again. Right now, you're just, it's sort of like a repeat from anatomy and physiology. It's the basic information is what you're going to want to know just for right now. So if you look at your book, it kind of explains it well. And I do have some video links that I'll post at a later date that will help explain it for those of you that learn best that way. You've got three different planes of the body. You got a sagittal plane, frontal plane, and a transverse plane. You also have three different axes of the body: sagittal axis, frontal axis, and a vertical axis. Okay, so a frontal plane passes through the body from side to side and divides the body into front and back parts. Okay, that is your frontal plane. It's also called the coronal plane. That's used interchangeably, but I will always refer to it as the frontal plane. Motions that occur are abduction and adduction that occur within that plane. Okay. You have a sagittal plane. A sagittal plane divides the body into right and left halves. So the motions that occur in that plane will be flexion and extension. Okay. Then you have a transverse plane. The transverse plane divides the body into top and bottom parts. It's like a horizontal cut of the body. Rotational movements is what occurs in this plane. All right. Then you get to the axis. The axis is a point that runs through the center of a joint. And any movement that occurs in a sagittal plane, because remember the sagittal plane cuts the body into left and right halves, will occur. The axis is a frontal axis. So any movement that occurs in a sagittal plane will occur on a frontal axis. Okay, and you might want to write that down because that's sort of a rule of thumb, and this will never change. Okay. Any plane, any movement that occurs on a frontal plane, which would be your AB and your adduction movements, it's going to occur around a sagittal axis. Okay. And then same thing with the transverse plane, your rotational movements. Any movement that occurs on a transverse plane is going to occur around a vertical axis. Okay, that's also called a longitudinal axis, but you will always hear me refer to it as a vertical axis. Okay, that's basically the information you need to know for this part of kinesiology. As we get further into kinesiology, and when you start the OTA 204 and 207 next year, when you're when you're actually in the program, or for those of you that are in the program, you'll get more of this in those courses. But for right now, that's what you need to know about this portion of kinesiology. Okay. So we're going to look at degrees of freedom. Joints can also be described as by the degree of motion or degree of freedom or number of planes that they're on. So if you think back to where we were going over the uniaxial, the biaxial, and the triaxial joint, this also refers to the number of planes in which a joint moves. So your uniaxial joint has 1 degree of free movement. Okay. Biaxial has 2 degrees of free movement, and triaxial has 3 degrees of free movement. Okay. So you got some common pathological terms that you'll need to know. You got dislocation. Dislocation refers to a complete separation of 2 articular surfaces of a joint. And they hurt. Subluxation is a partial dislocation of a joint. And normally that occurs over a period of time. Usually a dislocation happens in response to a trauma. Subluxation happens over a period of time. You see it most often with people who have had a stroke that can't move their shoulder or move their arm by themselves. You'll see dislocation or subluxation. Now, subluxation can lead to a dislocation. With proper management of the arm, a subluxation should never occur, or it should never get to the point to where it happens to be a dislocation. Okay. Osteoarthritis, that's a type of arthritis that's caused by the breakdown and eventual loss of cartilage. It's also known as degenerative arthritis. If you hear someone say, I've got degenerative joint disease, they have osteoarthritis. It's a fancy term for osteoarthritis. Okay, it's not anything that is any worse than osteoarthritis. As bad as osteoarthritis is, it's not worse than that. Sprains, that's a partial or complete tearing of ligament fibers. You got 3 different types. You got the mild, moderate, and severe sprain. You really need to seek medical attention, especially if you get a moderate to a severe, because tearing of the ligaments have occurred. A strain, that is a overstretching of muscle fibers. And it's graded, again, depending on severity, depending on how bad the pain is, will depend on whether you need to go seek medical attention. I've had strains and I've had sprains that weren't very serious, and, with a little bit of ice and elevation and rest, it's gotten better. And then I've had some that were pretty severe that I did seek medical attention for, and ended up in like a boot, or not a cast, but like just some type of a thing to keep it steady, to keep from moving it, so that it had time to heal. Tendinitis is an inflammation of a tendon. Synovitis is inflammation of the synovial membrane. Tenosynovitis is inflammation of a tendon sheath. Bursitis is inflammation of the bursa, and capsulitis is inflammation of the synovial capsule. Remember that you cannot fix an itis. The only thing you can do is pain management and give it time to heal. That's really all you can do for any type of an itis. Okay. Now, you do have review questions. They are on your OneDrive. Not OneDrive, sorry. They are on your eLearn Chapter 3 review questions. I'm going to let you all answer them this time. We will go over them in class, but I'm gonna, like I said, I'm gonna let you all answer those. Yeah, I got it on there. It's document 3 or OTA doc. It's document chapter 3. It's a Word doc. Get those uploaded. And I'll get them graded for you. So again, if there are any questions on this chapter, you can shoot me an email, and I'd be more than happy to answer for you. So just watch the video. And again, if you have, you can also look up, Google, interactive joint information. You want to specify of the human body, because you'll probably get a whole lot of information about pot if you just say joint. If you've got problems understanding it, and then we'll go over it again. So you all have a good rest of your day. Bye.